linear equations can be used to describe many real-life situations. Julio buys a used car for $5,900. Monthly expenses for the car, which include insurance, maintenance, and gas, average $180 per month. Write an equation that represents the total cost of buying and owning the car for X months. So what are the costs for owning this car? Well, first off, he has to buy the car. And buying the car is going to cost $5,900. Plus, then he's got monthly expenses, insurance, maintenance, gas, and that's all about $180 per month. It does say that X is going to represent the number of months. So you would take the number of months that he has the car times 180, and we could write that as 180X. And the total cost of owning this car we'll call Y. And this looks a lot like a slope-intercept equation. It would look more like slope-intercept if we flip the 180X and the $5,900 around. So I would accept either one of those as the answer. But when you have the X portion at the front, it looks more like a slope-intercept equation. Here's one more. The sales of a sandwich store increased approximately linearly from $52,000 to $116,000 during the first 5 years of business. Write an equation that models the sales Y after X years. Determine what the sales will be at the end of 12 years if the pattern continues. So this doesn't really specifically tell you how much more they earn per year. It just says that it goes linearly from $52,000 to $116,000 during the first 5 year of business. It does give you a little hint about what X and Y should represent. X represents the years and Y represents the sales. So we're going to use this information to create two ordered pairs. One of the ordered pairs is that in the first year, he earned $52,000. So that's one ordered pair. The second ordered pair is that after 5 years, the sales were $116,000. So since we know two ordered pairs, then we can write the equation of a line that goes through those two ordered pairs. So the first thing we would need to do is do the slope. So that would be 116,000 minus 52,000 over the X values of 5 minus 1. 116,000 minus 52,000 is 64,000 over 5 minus 1 is 4. And that would be a slope of 16,000. That's a big slope, but that's what the slope is. So now that we know the slope, we need to find the y-intercept. So we go to y equals mx plus b. We replace the y with one of the y values of the two ordered pairs that we know. And I'm going to use the smaller numbers because that should be easier to work with. So 52,000 equals the slope we just found, which is 16,000, times its x value, which is 1 plus b. 16,000 times 1 is just 16,000. And then we would subtract that 16,000 from both sides to solve for b. So we get b equal to 36,000. So if b equals 36,000 and we know the slope was 16,000, we can now write our answer, which will be y equals the slope that we originally found, that's 16,000 x plus the y-intercept we just found, which is 36,000. But that's only one part of the question. The second part of the question says determine what the sales will be at the end of 12 years if the pattern continues. Well, remember x represents years. So to figure out the amount of sales after 12 years is we're going to take our newly found equation and replace the x with 16,000. With 12 for 12 years. Plus 36,000. We will take 16,000 times 12, and 16,000 times 12 is 192,000, plus 36,000. And that means the sales after 12 years should be whatever 192,000 plus 36,000 is, and that is 228,000, and that is in dollars. So $228,000 if I give it a proper label.